Have you ever found yourself in a situation where your Kubernetes persistent volume claim just isn't behaving as you expected? It's frustrating, isn't it? If you're wondering whether you can change a persistent volume claim from ReadWriteOnce to ReadWriteMany without starting from scratch, you're in the right place. I totally understand your concern. Having a database pod that suddenly becomes read-only can throw a wrench in your plans. You're not alone in facing this issue. Many users have encountered similar challenges when working with Kubernetes. Here's the specific situation we're addressing today. One user asked, is it possible to change an existing PVC to ReadWriteMany from ReadWriteOnce without recreating it? They mentioned that their file system has become read-only, and they want to connect another pod to the PVC to investigate. Sound familiar? Let's dive into this together. So, what exactly is happening here? In Kubernetes, a persistent volume claim, or PVC, defines how storage is accessed. ReadWriteOnce allows only one node to write to the volume, while ReadWriteMany allows multiple nodes to read and write. Understanding this difference is crucial for resolving your issue. And stick around. At the end of this video, I'll share a pro tip that can help you manage your PVCs more effectively in the future. To change a persistent volume claim, or PVC, from ReadWriteOnce to ReadWriteMany, the user must first understand that Kubernetes does not allow direct modification of existing PVCs. Therefore, the first step is to create a new PVC with the desired access mode. Next, the user should define the new PVC in a YAML file. This file will specify the access mode as ReadWriteMany. The user can use the following example as a template. After defining the new PVC, the user should apply this configuration using the command line. This will create the new PVC in the Kubernetes cluster. Once the new PVC is created, the user needs to update the existing pods to use the new PVC. This involves modifying the pod specifications to reference the new PVC instead of the old one. Finally, the user should delete the old PVC if it is no longer needed. However, they must ensure that no pods are using it before deletion. Fun fact, did you know that Kubernetes was originally developed by Google? It's amazing how far it has come since then, helping developers manage containerized applications with ease. Now, let's look at the answers provided by other users. One alternative approach is to keep the existing PVC as is. The key point is that ReadWriteOnce refers to the number of nodes accessing the PVC, not the number of pods. You can create another pod that mounts the same PVC by using a node selector to ensure it schedules on the same node where the PVC is currently mounted. Alternatively, you can SSH into the node where the PVC is already mounted. Use the command kubectl describe to find the ID of the PVC if you have multiple mounts. Let's take a look at an answer from another user. This user explains that you cannot change a persistent volume claim from ReadWriteOnce to ReadWriteMany without deleting it. However, they provide a detailed procedure to do this safely. First, back up your existing PVC. Then, change the reclaim policy of the persistent volume to retain to prevent data loss. Next, scale down any workloads using the volume, delete the PVC, and free the persistent volume status. After that, change the access mode to ReadWriteMany, recreate the PVC with the new access mode, and scale your workloads back up. Finally, check that everything is working correctly and restore the reclaim policy if needed. Here's the pro tip I promised. Always plan your PVC access modes ahead of time. This can save you a lot of hassle down the road when you need to scale your applications. And there you have it. While you can't change a PVC's access mode directly, creating a new one and migrating your data is a solid workaround. If you found this video helpful, please hit the subscribe button for more Kubernetes tips, and don't miss our next video where we'll dive deeper into managing storage in Kubernetes.